110 degrees Fahrenheit. That is what Phoenix is forecast to hit by Monday afternoon, while the Salton Sea climbs to 112. Approximately 450,000 California residents are now under extreme heat watches that go active Sunday morning. And 3,000 miles east, a separate heat dome is breaking records that have stood at the same Florida weather station for 155 years. By the end of this video, you will understand exactly how one weather pattern is hitting both U.S. coasts at the same time, and what the institutions are quietly trying not to say about what comes next. Sunday morning, May 10th, through Tuesday evening, May 12th, 3 extreme heat watches go active across the desert southwest. Inside that watch zone, afternoon temperatures are forecast to climb between 105 and 112 degrees Fahrenheit. Approximately 450,000 California residents are inside that warning area, and they are looking at roughly 60 hours of dangerous heat. The numbers break down like this. The Salton Sea region of southwestern Imperial County is forecast for 105 to 112 degrees. The entire Phoenix metropolitan area is forecast for 104 to 110 degrees. The Coachella Valley, the San Diego County deserts, and the San Gorgonio Pass near Banning are forecast for 104 to 109 degrees. The hottest conditions are expected Monday, May 11th. Phoenix specifically is on a steep ramp into that peak. Today, Friday, May 8th, the Valley of the Sun is sitting around 101 degrees, which is already about 10 degrees above normal for the date. Saturday climbs to 104, Sunday hits 106, Monday tops out near 108. All 3 of those peak days have been flagged as first alert weather days by the National Weather Service. Now, the technical detail matters here. These forecast values are approaching historical daily records for early May in Phoenix, but in some cases, they are not breaking them. What makes this event genuinely unusual is not that any single number is the hottest temperature ever recorded on a given calendar day. It is that the desert southwest's seasonal ridge has not typically established this strongly, this early, this far above normal. The calendar says it is the second week of May. The atmosphere is acting like the second week of June. The National Weather Service has classified the threat as a major heat risk, which is the second highest tier on the 4-tier NWS heat risk scale. That classification means heat-related illness probability is significantly elevated even for populations that are acclimated to desert summers. People who live in Phoenix and Palm Springs are not casual about heat. When the NWS calls a major heat risk in early May, the warning is calibrated to people who handle 110 in August without complaint. The watches were issued by the NWS Phoenix office on May 7th at 11:33 at night Mountain Standard Time, and by the NWS San Diego office on May 8th at 3:42 in the morning Pacific Daylight Time. They drop simultaneously. They cover 3,000 square miles of populated desert. But the desert southwest is only half the story. 3,000 miles to the east, a separate heat dome is doing something even more impressive on a different metric. It is breaking records that have been standing for over a century and a half. Jacksonville, Florida, has a downtown weather station with a continuous observational record going back 155 years. That station has been logging daily temperatures since shortly after the end of the Civil War. On May 7th, that station was forecast to reach 95 degrees Fahrenheit, which would constitute a daily record at that gauge. Take a moment with that. A daily record at a 155-year station means the value exceeded approximately 154 prior May 7th observations. Recorded at the same location, every May 7th, since just after the Reconstruction era, every May 7th through both World Wars, every May 7th through the Dust Bowl, through the Great Depression, through every El Niño the modern instrumental record has documented. The previous high for that calendar day held through all of it. This week, it fell. 11 degrees above normal for the date. Not 3 degrees. Not 5. 11. Jacksonville is not alone. Other Florida cities ran with it the same week. Orlando was forecast for the upper 90s on Thursday, May 7th, placing the city near or at the daily record of 98 degrees. Melbourne was forecast for 94 degrees against an existing daily record of 91. Miami's forecast high of 94 could tie or break a daily record set in 2022. Tampa Bay area forecast for the week placed daily highs in the mid-90s, near records but below the all-time city peak. I want to flag something specific here, because the news cycle has gotten this confused. Tampa first hit 100 degrees on July 27th, 2025. Last summer, not this week. That all-time record was set 10 months ago. What is happening in Tampa this week is dangerous early season heat, but it is not a new all-time city record. The records that are falling this week are at Jacksonville, Melbourne, and potentially Miami and Orlando. The daily records for early May, which is what makes the timing of this story so unusual. Now, the more dangerous part of the southeastern story is what is forecast for Sunday and Monday. Inland portions of Palm Beach County, Broward County, and Miami-Dade County are forecast to reach extreme heat risk on May 10th and 11th. That is the highest tier on the 4-tier NWS heat risk scale. The same Sunday-Monday window when the desert southwest peaks at 112 degrees at the Salton Sea is also the same window when southeast Florida hits the top tier of its own scale. The NWS Miami area forecast discussion of May 8th at 7:54 in the morning Eastern Daylight Time captured the situation directly. Above average temperatures continue today and will continue through the weekend. Probabilities of heat-related impacts across urban areas during this time frame remain high. The same product flagged a 15% probability that parts of metro southeast Florida will reach extreme heat risk on Saturday, and that probability climbs into Sunday. The mechanism in Florida is a strong upper-level high-pressure system parked over the Caribbean. That ridge is, in the words of the NWS Miami office, nearly directly overhead. It is dragging the entire southeastern United States into a state of compressed, sinking sun-baked air that is not letting go. Here is the part of the Florida story that does not show up in the daily record headlines, and it is the part that actually kills people. The human body relies on overnight temperature drops to dissipate accumulated daytime heat load. When the air at 3 in the afternoon is 95 degrees and the air at 3 in the morning is 68 degrees, your body has a window in which it can cool itself off, restore physiological balance, and prepare for the next day. When the air at 3 in the afternoon is 95 degrees and the air at 3 in the morning is 81 degrees, that window does not exist. The cumulative heat load builds. The body cannot recover, and after several consecutive nights of that, heat-related mortality starts to spike. South Florida overnight lows for this weekend are forecast to remain in the upper 70s to low 80s. Coastal locations are not expected to drop below 80 degrees overnight on Saturday or Sunday. The NWS Miami office described the resulting overnight condition with 3 words: stagnant, soupy, uncomfortable. The upper level ridge is nearly directly overhead, which means there is effectively 0 overnight wind to mix the air. 3 consecutive nights with lows above 80 degrees is unusual for early May. That kind of overnight floor is more characteristic of mid to late summer in South Florida, July, August, into September. Hitting it in early May puts the system into a configuration the audience normally associates with hurricane season before hurricane season has even started. The combination of high daytime heat and elevated overnight lows is the configuration most associated with heat-related mortality. Outdoor workers, the elderly, the medically vulnerable, people without air conditioning, people who lose power during the heat. The cumulative stress on those populations builds rapidly over a multi-day event with no nocturnal cooling. That is why extreme heat risk, the top tier on the NWS heat risk scale, is being triggered in metro southeast Florida in early May. That alert is calibrated to evidence-based heat-related morbidity thresholds derived from county-level mortality data. It is not used casually. Triggering it in early May is well outside the seasonal envelope when that alert is typically active. So the question becomes, how is it possible that the desert southwest is hitting 112 degrees and the southeast is hitting top-tier heat risk at the same time? The answer is in the upper atmosphere, 18,000 feet above the ground. The 500 millibar pattern as of May 8th shows 2 distinct ridges separated by a continental trough. The western ridge is amplifying over the Pacific Northwest and the desert southwest. The eastern ridge is anchored over the Caribbean and extends north over Florida and the southeastern United States. A narrow cold front trough tracks south through the central United States, separating the 2 ridges and producing a slight risk severe weather corridor across Oklahoma and North Texas. This configuration is approximately what meteorologists call an omega block. Picture the Greek letter omega, a strong central ridge flanked by lows on both sides, and you have the shape. Except in this case, the United States gets 2 of them side by side. The western omega over the Pacific Northwest, the eastern omega over the Caribbean, and in between, a continental trough drives Friday and Saturday, severe weather across Oklahoma into North Texas. When a ridge becomes quasi-stationary like this, the air inside it sinks. As that air sinks through increasing atmospheric pressure, it compresses, and compression heats it at a rate of approximately 5.5 degrees Fahrenheit per 1,000 feet of descent under dry adiabatic conditions. At the same time, the ridge suppresses cloud formation, so incoming solar radiation hits the ground unobstructed, and the surface heats further. The 2 effects compound. Air gets compressed and heated from above, the sun heats the ground from above with no clouds to block it, and the heat dome locks in. That is the mechanism. Sinking air, compression heating, clear skies, solar maximum. Stationary ridge, days to weeks. Now, here's the part that should hold your attention. The same synoptic configuration producing the two heat domes is simultaneously producing two more hazards across the country. On the backside of the western ridge, the northwest flow is delivering 15 to 30 mile per hour winds, gusts to 40 miles per hour, and relative humidity in the 10 to 20% range across Montana, North Dakota, South Dakota, and Minnesota. 8 red flag warnings are active simultaneously across those 4 states. The NWS Glasgow office in Montana is flagging a 20 to 50% chance of dry-leaning thunderstorms, which is the worst-case ignition mechanism for early season fire weather. NASA satellite data shows 383 active fire hotspots across the country in the past 24 hours. None of them are flagged as high intensity yet. But the ignition profile across the northern plains today is the kind that turns into headlines tomorrow. Meanwhile, in the trough between the two ridges, the Storm Prediction Center has a slight risk severe weather outlook for much of Oklahoma and North Texas. Large hail, damaging winds, a few tornadoes possible for tonight and into Saturday morning. A second slight risk day is forecast for southwest Oklahoma and northwest Texas Saturday into Sunday. So count it up. 1 synoptic configuration, 4 distinct hazards. Desert Southwest extreme heat in the western ridge core. Southeastern U.S. Extreme heat in the Caribbean ridge. Northern plains, fire weather on the backside of the western ridge. Southern plains, severe weather in the central trough between them. 178 active National Weather Service alerts nationwide, one pattern producing all of it. 6 weeks ago, in March 2026, the western United States was hit by what Yale Climate Connections has classified as one of the 6 most astonishing extreme weather events of the 21st century. The numbers from that March event are worth saying out loud. 7,000 daily highs broken across the country, 2,000 monthly records broken. A new United States national March temperature record of 112 degrees, exceeding the prior national March record by 4 full degrees. March 2026 was the warmest March in continental U.S. 132-year observational record, at 9.4 degrees above the 20th century average. That was March, not July, not August, March. The World Weather Attribution analysis of those March temperatures concluded that the record-shattering heat was, quote, virtually impossible without climate change. The return period for that event under a stable pre-industrial climate exceeded 500 years. That means if the planet's climate had not warmed since 1880, an event of that magnitude would happen once every 5 centuries. The mechanism that produced the March event was different from what is happening today. In March, a Kona storm over Hawaii produced an atmospheric river that transported upper-level heat eastward and built the southwest U.S. ridge to record strength. Today's event is the Omega Block dual ridge configuration described in the previous section. Different mechanism, same result. The two events are mechanically distinct but climatologically connected. Here's the part that should keep you awake. The May 8th event, with its 500-year class precedent 6 weeks earlier, is now the second extreme early season heat event of 2026. 2 500-year class heat events in the same calendar year, in different regions of the country, less than 2 months apart, at a base state global temperature that has never been observed in the modern instrumental record. This is not isolated weather. This is sequencing. And it is happening during a week in which the institutional climate community has, for the first time, started to use specific words about what is going on. The May 8th heat dome is happening during the same week. Mainstream media is finally publishing what climate scientists have been saying for 2 months. The Boston Globe ran the headline on May 7th. Quote, strongest El Nino on record may be coming in 2026. Time magazine's framing, is a super El Nino coming in 2026? Weather.com on May 7th. Super El Nino increasingly likely, could be record strong. Yale Climate Connections. The planet hasn't seen an El Nino on this scale since 1877 to 78. We covered the El Nino forecast itself last week in depth. The forecast itself was the story then. Today's video covers what the forecast looks like in real time when the heat actually arrives. The current Oceanic Nino Index is plus 0.11 for the February through April 2026 season. 6 months ago, it was minus 0.51. The Pacific has warmed approximately 0.66 degrees Celsius in 6 months. The basin sea surface temperature anomaly has crossed zero from negative to positive. That is among the fastest cool-to-warm transitions documented in the satellite record. April in 2026. Equatorial Pacific subsurface heat content is the highest for any April in the satellite era, which began in 1979. It is also the highest for any month since 1997. There is now more warm water below the surface of the equatorial Pacific in May 2026 than there has been at any equivalent point in the last 28 years. And 1997 was the precursor signal for the most powerful El Niño in modern instrumental history. The NOAA Climate Prediction Center, April 2026. ENSO Diagnostic Discussion places El Niño emergence probability at 61% for May, June, or July. Persistence through end of 2026 is 88 to 94%. The probability that Niño 3.4 exceeds plus 2.0 degrees during NH winter 2026 to 27, which is the threshold for Super El Niño classification, is approximately 25%, 1 in 4. The CFS V2 forecast plume issued on May 1st did something that has not happened before in modern operational forecasting. The y-axis on the chart was physically extended for the first time in the history of the operational product from a previous plus 3 degrees Celsius ceiling to a new plus 4 degrees Celsius ceiling. The reason was straightforward. Forecast members were running off the top of the chart at the previous range. The agency had to extend the visualization because the model output had outgrown the existing display. The multi-model December 2026 Oceanic Niño Index median forecast is plus 2.9 degrees Celsius. That value would exceed the 2015-16 peak of plus 2.6. It would exceed the 1997-98 peak of plus 2.4. It would exceed the 1972-73 peak of plus 2.1 and the 1982-83 peak of plus 2.2. Every single Super El Niño peak in modern instrumental history, it is a value that has never been forecast operationally before. So here is the connection back to today's heat dome. On the May 8th weekend, with 112 degrees forecast at the Salton Sea and a 155-year record falling in Jacksonville, is happening before the El Niño has formally arrived, before the trigger, before the peak. The pre-trigger heat is already breaking century-and-a-half records on both coasts at the same time. That is the operational consequence of what the forecast says is coming. This is the editorial center of the title. The data is producing forecasts the institutions are not yet ready to fully endorse. NASA scientist James Hansen published on his Substack between April 30th and May 1st. His position is direct. 2026 will surpass 2024, currently the warmest year on record at plus 1.55 degrees above pre-industrial, as the warmest year ever recorded. 2027 will be hotter still. Hansen is calling it definitive. Berkeley Earth climate scientist Zeke Hausfather, writing on the climate brink on April 30th, was more measured. He placed the probability at 26% for hottest year, 56% for second hottest year. His central estimate puts 2026 at plus 1.47 degrees above pre-industrial. Conservative. The UK Met Office, in its December 2025 Outlook for 2026, published a central estimate of plus 1.46 degrees. UK Met Office head of seasonal prediction Adam Scaife went on the record in New Scientist on May 1st and explicitly called Hansen's forecast premature. His specific objection is that the spring predictability barrier, which is a known structural limitation in ENSO forecasting that historically degrades forecast skill at 6 to 8 month lead times, has not been fully crossed yet. And forecasts made before midsummer carry uncertainty bands wide enough that definitive language is, in his words, premature. The World Meteorological Organization's institutional language has settled on this, particularly rapid development, possibly unprecedented since the beginning of modern observations. That is the gap. Hansen says definitive. Scaife says premature. The WMO says possibly unprecedented. And in between those positions, the May 8th Dual Coast Heat Dome is the first concrete weekend during which the audience can see in their own cities what the data has been saying for 2 months. The institutional review cycle is slower than the data is moving. That is what has forecasters on edge. The numbers being produced by the operational models are values that have never been forecast before, and the institutions whose job it is to communicate those values to the public are caught between getting it wrong by overstating and getting it wrong by understating. Hansen has chosen to take the risk of overstating. The Met Office has chosen to take the risk of understating. The data does not care about the institutional debate. The May 8th weekend is the first time the audience gets to look at the data themselves and decide which side of the gap they think the actual answer sits on. There is one viral framing actively circulating online about all of this, and the data inverts it. The framing is that the heat dome and the El Niño signal are being amplified by geoengineering or weather modification programs. The peer-reviewed evidence runs in the opposite direction. A 2025 paper in the journal Earth's Future modeled the effect of marine cloud brightening over the eastern subtropical Pacific. That technique is the most plausible candidate for any kind of large-scale Pacific climate intervention. The modeling found that marine cloud brightening would suppress El Niño amplitude by approximately 61%. The opposite of amplification. If you wanted to weaken the signal, marine cloud brightening would do it. Nobody is doing it, but if they were, the El Niño would be weaker, not stronger. The IMO 2020 sulfur cap is a related point worth getting right. That regulation removed an unintentional cooling forcing from global shipping fuels by reducing the sulfur content of bunker fuel for air quality reasons. It is a real, transparent international air quality regulation made for human health reasons, not a covert program. The cooling forcing it removed has produced approximately plus 0.046 degrees of additional radiative warming. It has been measured, it has been published in Communications, Earth and Environment in 2023, and it has been replicated by independent modeling groups. The number is real, the mechanism is real, the regulation is public. What it is not is a conspiracy. And finally, there is the energy budget argument, which is the most decisive one. A continental heat dome involves an energy budget of approximately 10 to the 22nd power joules. All weather modification capability that any government on Earth currently possesses, combined, operates at 10 to the 10th through 10 to the 12th power joules. That is 10 to 12 orders of magnitude short. The 77 expert consensus survey from Shearer, West, Caldera, and Davis in 2016 confirmed that there is no plausible mechanism for any current technology to drive a continental heat dome. The heat is real. The El Niño is real. The records are real. And nothing in the peer-reviewed literature supports the framing that any of it is being driven by something other than the climate system itself. The May 8th event is the second extreme early season heat dome of 2026. That is the first thing to remember. The second thing is that the Western Ridge is forecast to strengthen further during the May 13th to May 17th window. Long-range model guidance shows the western two-thirds of the lower 48 states under significant above-normal temperature anomalies during that period. The Salton Sea peak Sunday into Monday is not the end of the western heat regime. It is the opening act. The eastward progression of the front during the weekend is forecast to weaken the southeastern Caribbean ridge slightly by Tuesday. South Florida gets a brief reprieve in midweek, but ridging is forecast to rebuild during the second half of next week, and overnight lows will return to the upper 70s and low 80s. The National Hurricane Center officially begins Atlantic hurricane season on June 1st. Routine NHC tropical weather outlooks resume on May 15th. Tropical Storm Hagapit at Yap Coastal Waters has already produced a U.S. tropical storm warning a full week before the NHC desk reopens. The first U.S. tropical strike of 2026 is happening before the season formally begins. The Super El Niño forecast peaks October through December 2026. Hansen and the UK Met Office both agree, despite their disagreement on 2026, that 2027 will likely be hotter than 2026. The timeline runs straight through the rest of the year. I want to put one historical data point on the table briefly because the audience deserves to know what the reference class actually looks like. The 1876 to 1878 Great Drought is the only historical event of comparable forecast magnitude. It killed an estimated 30 to 60 million people across India, China, Brazil, and Northeast Africa. That happened in a world without air conditioning, without a National Weather Service, without satellites, without heat risk products, and without the National Hurricane Center, without NOAA. The infrastructure now is incomparable. The base state global temperature is incomparable because the baseline is plus 1.3 to 1.5 degrees Celsius warmer than 1876. The two events are not directly substitutable, but the climate system loading is comparable enough that the audience needs to ask one specific question. If pre-trigger heat is breaking 155-year records on both coasts simultaneously, 6 weeks after a 500-year class March heat dome before El Niño has formally arrived, what does the actual peak look like? The forecast trajectory says Niño 3.4 peaks in October through December 2026 at a multi-model median of plus 2.9 degrees Celsius. That value exceeds every prior Super El Niño in modern records. The base state warming is plus 1.3 to 1.5 degrees Celsius above the 1880 reference. The total system loading is unprecedented. Hansen has told you what he thinks. The UK Met Office has told you what it thinks. The data is moving faster than the institutional review cycle. The May 8th weekend is the first concrete moment the audience can look at the operational forecast in real time and decide which institution they trust. The Sunday-Monday peak this weekend will provide the next operational data point. The NHC Tropical Weather Outlook resumes May 15th. The NOAA Climate Prediction Center releases its June ENSO diagnostic discussion in the first week of June. Each of those updates is going to land into the same data picture this video has just laid out. We'll be tracking it as it develops. Thanks for watching the Space Desk. I'll see you in the